Welcome dear student. Welcome again to my channel Talking Physics with P.R. Sarkar. So today we shall discuss about something new topic which is very essential for this chapter, which is known as electrostatic potential. So in the previous day we can know about electrostatic potential. That is the definition of electrostatic potential and the mathematical expression of electrostatic potential. We also know what is electric field. For convenience, I say again that what is electric field. Now, if in a charge, that is source charge Q, there is another test charge which is very small compared to the source charge is placed, then the test charge, that is the unit positive charge, experiences a force. A source charge is Q which is exert a force at a test charge Q0, which is given by 1 by 4 pi epsilon naught Q by R square, if the distance between the source charge and test charge is R. And if Q is positive, the electric field is away from the electric field and the force is away from the positive charge. In the same manner, we know that the potential at point P, suppose this is point P and this is point O, at point P due to the charge Q is given by 1 by 4 pi epsilon Q by R. So अभी तक हमने इतना ही जाना है कि इलेक्ट्रिक फील्ड एंड पोटेंशियल का एक्सप्रेशन क्या है. सो टुडे वी लर्न अबाउट द रिलेशन बिटवीन E एंड V एंड हाउ वी कैन डिटरमाइन if the potential is known, the electric field, or if the electric field is given, the corresponding potential. Okay, so let us start. The relation between electrostatic potential and electric field. Let us consider a charge Q is placed in an electric field E, positive source charge Q. This is called source charge. Positive source charge Q is placed at a distance R from a test charge Q0. Therefore, the force exerted by Q0 on Q0 due to this source charge is Q0 into E. We know this, that the force exerted on the test charge, that is unit positive charge, it is called test charge, it is always taken unit positive charge. We know it, unit positive charge. Again, if we take any two other point on the same axis, one is A and other is B, and the distance between A and B is very small, that is dr. Now, if we take a unit positive test charge Q0 from A to B, then against this electrostatic force, then the work done is given by F dot dr. We know it, that we may take the positive charge from A to B against electrostatic force. So the force is, the work done is F dot dr. Now the direction of force and the direction of displacement is opposite. So this is F dr cos 180. Put the value of F, Q0 E, dr cos 180 is minus 1, that is minus Q0 E dr. Again, from definition of work done, we can know that work done is Q0 difference in potential. between the two given points. That is, charge into potential difference is the work done. That is Q0 into VB minus VA. VB minus VA is taken that from the potential of the final point minus initial point, as the potential of B is higher than A. Okay, so we have to done some external work to bring the test charge from A to B. So if we take a very small, if VB and VA are nearly equal, so their difference is very small, you can take it capital V. Now if we equate the two equations, we can get Q0 dV is equal to minus Q0 E dr. Q0 cancel out, we can get dV is equal to minus E dr, or we can say E equal to minus dV dr. This is the basic formula or basic relation between E field, that is electrostatic field, and potential. So very important, E equal to minus dV dr. Now dV dr is known as change in potential or change in potential per unit distance. It is also called potential gradient. It is also called potential gradient. Gradient means change in potential gradient. DIENT. Gradient means change in of a physical quantity with respect to distance. Potential, change in potential with respect to distance. Per unit distance, the potential change. So electric field is basically equals to negative of potential gradient. Electrostatic field, I repeat, electric field in a region is equal to the negative of potential gradient. That means the V increases in the decreasing direction of E. V increases in the decreasing direction of E. As in the above figure, E is increasing along positive x-axis. If this is taken as origin O, then E is increasing along positive x-axis. So V is decreasing along positive x-axis. Okay. So as we go from the origin, electric field increases but potential is decreases. So if we take spherically symmetric charge of equipotential surface, what is equipotential surface, what is its property, in the next video I will discuss. So in this case, okay, in this case, the as we go from the outside, the E is increased but the potential is decreased. This is the physical significance of dV dr. Now how can we find out this potential? Okay, please write down in your copy. How can we find out the potential? So from this equation, that is E equal to minus dV dr, we can assume that there are 2 points R1 and R2. There are 2 points R1 and R2. R1 and R2. Okay, this is R2, this is R1, and we have the potential of R1 is V1 and the potential is R2 is V2. So we have to take a unit positive charge from V2 to V1. So we can say that E equal to minus dV dr. Okay, so dV equal to minus E dr. Now take the integration because we have to find out the total work done, okay, or total potential. So we can differentiate it from V1 to V2, R1 to R2, okay, E dot E dr. R1 to R2. Now, as per the definition of electrostatic potential, that to move a unit positive test charge from infinity to any point. Okay, so if this is point infinity, and a very important point you have to remember that as the electrostatic force is conservative in nature, so the potential difference between 2 points does not depend on the path. It depends only on initial and final points. So इन्फिनिटी से लेकर R2 पॉइंट में अगर यूनिट पॉजिटिव चार्ज को लाना होगा इन एनी पाथ, द पोटेंशियल डिफरेंस और वर्क डन में बी सेम. इट ओनली डिपेंड्स ऑन इन्फिनिटी एंड द पॉइंट. सो फॉर आवर कन्वीनियंस वी कैन से दैट in the same axis infinity is a point which is far away from R2. So if we have to consider the point R1 as infinity, if we has to take R1 as infinity, here a unit positive test charge is located, so the potential of R1 we shall take V1 infinity equal to 0. So we have to put it 0 and V2 equal to V of R. So we can say it V2 minus V1. So we can say it that V2 minus V1 equal to minus, we can say R1 to R2 E dr. Now from this V2 equal to V of R as V1 equal to 0 equal to minus integration infinity to R E dr. So this is the required conditions to find out potential V of R equal to minus infinity to R E dr. Not E dot dr because we can take cos 180 minus 1 E dr. Okay. So in this way we can find out the potential and the electric field of any point. Okay. Now we go with two very important problem, because you know without any numerical example the concept will not be clear. So numerical number 1, numerical number num1, that is numerical number 1. The potential at a point along x-axis due to systematic charge condition is given by 20 by x square minus 4 volt per micrometer. 20 by x square minus 4 volt per micrometers. Find out electric field for x equal to 4 micrometer and also its direction. How can we solve this? Due to systematic charge, due to systematic charge on a positive x-axis, this is x-axis, the potential is given, we have to find out electric field. So as we know that E equal to minus dV dr or dV dr. Okay. So here only it is considered x-axis. So the y and z component is 0. So we can say it E equal to minus dV dx. So minus ddx of V, that is 20 by x square minus 4. I sure that you will do this derivative. अगर नहीं पता है तो प्लीज़ मैथ में प्रैक्टिस कीजिए. ddx of 20 is constant, so it is outside the derivative. Okay, so we can get it at minus 20 ddx of x square minus 4 to the power minus 1. Okay, so we can get minus 20 into minus 1 into x square minus 4 to the power minus 2, and derivative of x square is again 2x. So we can get finally 20 into 2x divided by x square minus 4 square. Okay, that is 40x. We can get 40x by x square minus 4 square. This is the value of electric potential. Now we put the value x equal to 4 micrometer. Okay, I hope you will write down the problem. So as the space is very small, so we have to wipe out it. So E is given by 40 into 4 divided by 4 square, that is 16 minus 4, 12 square, or 160 upon 144. So if we take the smallest ratio, then it is 10 by 9. We can divide it by 16. 16, 10, 160, 16, 9, 144, that is 10 upon 9 volt by micrometer. So this is the required electric field we can get. In any problem, you have to only differentiate or integrate. If potential is known, electric field find out, differentiate. If electric field is known, find out potential, integrate. Okay. So now we go to the next level math, numerical number 2. तो बच्चों, अगर आपको मेरी टीचिंग अच्छा लगा तो प्लीज़ सब्सक्राइब कर दीजिएगा फॉर न्यूली इंटरेस्टिंग मैथमेटिक्स. ओके, नंबर 2, E is given by 30x square I cap. Find out the potential difference VA minus V0, where VA is the potential at x equal to 2 meter and V0 at potential at x equal to 0. So in language the problem should be like this. The electric field of any region is acted upon 30x square I cap, that is along x axis. Find out the potential difference. Suppose this is V0, this is VA. Put an electric field is 30x square. It is acted upon x axis. So it is I cap. So find out the potential difference between the 2 points V0 and VA. V0 is located at origin O, as the intersection point of x and y axis is, we know, always origin 0, 0 point, and VA equal to x equal to 2 meter. So this is 2 meter. Find out the value. So this is the reverse process of the previous math. Okay, so we can get E equal to minus dV dx or dV dr. So dV equal to dV, that is dV equal to VA minus V0 or V0 minus VA equal to, we can get that minus E dx, that is minus E integration 0 to 2 into dx, that is 30x square dx. So minus, so you can get VA minus V0 equal to minus 0 to 2 30x square dx. But here the potential should be VA minus V0. Okay, here the potential should be V0 minus VA, V0 minus VA. So because we know that the potential of VA minus V0, so we can get here VA minus V0 equal to, this should be plus 30 into integration 0 to 2 1/3 x cube, x square differentiation 1/3 x cube. So you can get 30 into 1/3 x cube, 1/3, sorry, 0 to 2, that is 1/3 into x cube means 8 minus 0. So 10, and 10 into 8 is 80 volt. Okay. So we can find out E as we can find out E as V is known, and we can find out V as E is known. So we can get this value 80 volt. So in this way we can find out different problems related to electric field and electric potential. There are lots of problems. If you like my video, or if you want to practice various problems, please write me in my comment box. I will definitely do it for you and I will try my level best. So बच्चों आज के लिए इतना ही. So मिलते हैं अगली वीडियो में इक्विपोटेंशियल सरफेस को लेकर. और for 11 students I say that we will come with the next day the laws of motion, the basic of force and the numericals. Okay, so keep watching my video. If you like my video, subscribe. Thank you.